The next topic of discussion is network address translation. Network address translation is the process of translating or converting a private IP address to a public IP address. Which brings us to, what is a private IP address? Well, the International Engineering Task Force has described in the article RFC 1918, and RFC actually stands for Request for Comments, and these are the original IEEE documents that define protocols and standards in our networking community. So OSPF has an RFC, RIP has an RFC. So RFC 1918 describes the ranges of addresses that are not allowed on the internet. So if you hit a service provider router with a source address from the private address range, you will either get a warning, or because the service provider is going to think that you are trying to do something malicious. So these addresses are simply just not allowed on the internet, and they are not globally routable. Companies, private companies, are allowed to use this address space within their environment. But if they try to send traffic out to the public internet, they need to translate to a public address. Now, these addresses are the 10 range, 10.0.0.0, through 10.255.255.255, or the 10/8 prefix. Now, if you ever see addresses written like this, do not get confused. It's simply a lazier way of expressing the 10 network. So for example, let's say if I have a classless network, 150.101.0.10.10/21, I can depict this as 150.101.0.0/21, or, so this being the IP address, this being the network address, and I can even shorten it further to 150.101/21, leaving out the last two octets because they're zeros anyways. So if you ever see an address depicted like that, just assume the rest of the fields are zeros. Now that's the Class A range. In the Class B, you have the 172.16.0.0 through 172.16.31.255.255 with a /12 mask, or the 172.16/12 prefix. Prefix just means the length of the mask or the network address. So the network address over here is 172.16/12. And then they have a Class C range, which goes from 192.168.0.0 through 192.168.255.255/16. If I were you, I would memorize these addresses, because on the test, you might be asked to pick between private and public addresses. And they usually get people by giving addresses close to the back end of the Class B range. Now, to do NAT, we're going to do a lab soon, but the easiest way I personally have seen, or I personally memorize these, is to just break it down, or the configuration, you break it down into 4 steps, 4 simple steps. So, let's say you work at a company and they are using private addresses, and now you need to go to the public internet to do business. And somebody gets assigned to go buy public addresses. So the point I'm trying to make here is that you have to go purchase a pool of public addresses. Now the pool could be 254 addresses, 50 addresses, or maybe just 1 address. Now the corner case of the pool being 1 address we'll explore in a little bit. But the bottom line being, initially when you want to go on the internet and your private firm needs to do business on the internet or go through the internet to another private company on the other side of the internet in another country, you need to create a pool of public addresses on your router. You purchase these addresses, and let's say our pool, when we do our lab, let's make our pool, let's say we went and got the 190.10.10.0/24 pool. That's a pretty big pool. It doesn't really work out like that in the real world. And we'll explore a real world scenario in a bit. But let's first understand how NAT works before we get into more complicated scenarios. So this command is, I should stay on this side of the board. The command syntax is ipnat pool from config mode, then the pool name. You simply name the pool. We can call it CCNA. Then you assign the first address. So from the 190.10.10.0/24 range, the first address will simply be .1. Then the keyword net mask, and then the subnet mask. And our subnet mask in this case is, well, no, the first address, 190.10.10.1, that goes here. Then the last address, which is 190.10.10.254.255 being my broadcast. So the last address goes here, 190.10.10.254. Then the keyword net mask, and then the subnet mask, which will be 255.255.255.0. After that, step 2 is to permit your private address translation using an access control list. So I actually have to tell the router, hey, allow these private addresses into translation. Allow them to get translated. So for that, I simply use a standard access list. And I create it using the IP access list standard, and then give it a name command. We can call it Cisco. And then you permit. You will always permit. You're not going to deny, but the command syntax for access control list is permit or deny. Forgot this little bracket here. So you will permit, in this case, always, the network. So let's say our private network is the 10.10.10.0 network. So the network address will go here, and then the wildcard, which, if it's a /24 network, will be 0.0.0.255. Then the next step, step 3, is to simply tie step 1 and step 2 together with the IPNAT inside source list. So it's basically asking, if you read the command syntax, it's asking IPNAT, I'm going to do NAT, using the inside source access list, inside source list, and our list was called, I believe I called it CCNA, or no, Cisco. So the name, whatever name I put here in my access list goes here, and then pool, and then the pool name, which I believe we chose as CCNA. So our pool is CCNA, and our access list is Cisco. And then the keyword overload, we're going to ignore this for now. As I said, when we explore a more real-world scenario, we will look at this keyword. So for now, you'll just hit enter. Then you have to go apply your NAT. So let's assume that, let's just say you have a router 2, let's say. And you have F0/1 on this side and F0/0 on this end. And let's say this end faces your domain. So this is your domain. And let's say F00 faces the internet or your service provider router. So this would be your inside interface, and this guy, F00, would be your outside interface. So you apply NAT by basically going inside each of these interfaces by saying interface ID. So for example, if I was going under the inside interface, I would say int F0/1, in this case, above. And then I would simply say IPNAT inside on F0/1, and then I would go into F0/0 and say IPNAT outside. Now to check my work, once traffic has passed through my translating router, I would do the command or execute the command show IPNAT translations. And if for some reason I wanted to clear those translations out, my command would be clear IPNAT translations. Actually, there's a star after that. Clear IPNAT translations star. This concludes the lecture part, but let's go see how this works in a lab.